Have you ever come across something that looks really innocuous, simple, and beautiful, but there is a layer of sophistication about it that you just cannot figure out? Hi everyone, welcome back. Today I'm going to talk about one such problem I encountered around 8 years ago, and naturally I could not solve it for many days. The problem is we have to construct a hexagon which has following two properties. One is that all of its interior angles have to be 120 degrees, and second is kind of tricky that its sides cannot be equal. We have a hexagon whose sides are 1, 2, 3, 4, 5, and 6 units respectively, but all of its interior angles are equal to 120 degrees. The first question that comes to mind, that came to my mind as well, is that is it even possible to have such a hexagon? Is it even possible to have a hexagon with all equal angles but different sides? The answer is yes, surprisingly, and let's see how is it possible. Consider this hexagon that you can see on the screen. This is a hexagon. All of its angles are 120 degrees, but you can very clearly see that the sides are of different lengths. Some sides look equal, but at least there are some sides whose length is different to each other. So it is possible to have such hexagons whose all angles are equal, but we have different sides. Not only this, I can construct as many hexagons like this as I want by simply doing a little bit of construction, by drawing a couple of parallel lines. Let me show you how. I'm going to draw one line here, which is going to be, let's say, parallel to this, and one more line here. This is going to be parallel to this line. You can very clearly see that since these lines are parallel, if this angle was 120 degrees, then this angle is also 120 degrees, and the same goes for all other angles as well. So we can construct as many hexagons as we want, and all of these hexagons are gonna have same angles, 120 degrees, but some of the sides are definitely going to have different lengths. And this is not the case only for hexagons. We can construct rectangles as well. Rectangle is a classic case. That rectangle, by definition, let me choose another color. The rectangles by definition have all angles 90 degrees, but the adjacent sides are supposed to be unequal, right? So it is possible to construct such polygons. The case is little bit different in case of triangles. In triangles, we have equilateral triangles, and in equilateral triangles, all sides are equal as well as all angles are equal. Not only that, in a triangle, it is not possible to construct a triangle such that all sides are equal but we have different angles, and vice versa. In case of triangles, equality of angles directly implies the equality of sides, and vice versa. So let's not talk about triangle for now. We are going to stick to our problem. We want to construct a hexagon which has these two properties. Now let's see how are we going to do that. The solution is really elegant. Let's see. First step, I'm going to construct an equilateral triangle. You can see we have an equilateral triangle ABC. It has sides measuring 9 units each. In the second step, I'm going to mark some points very strategically, like this. 2 points here. Let's call these points as P and Q. 2 points I'm going to mark here. We will name these also, and as you might have guessed, I'm going to mark 2 more points. Now the important thing here is that these points are very strategic in the sense that length of AP, length of AQ both are going to be 1. Similarly, let's call these points as R, S, T and U. So BR is going to be 2, BS is going to be 2, and as you can guess, CT is 3 and CU is 3. Why did I say strategic? The reason is going to be clear really soon. What I'm going to do next is that I'm going to join these points. I'm going to join PQ, RS and UT. Since these lengths are equal, let's focus on the triangle APQ. Since these two lengths are equal, so I'm going to have an isosceles triangle with these two angles as equal, and angle A was already 60 degrees. I can say that triangle APQ is an equilateral triangle. And by extension, I can say that triangle BRS and triangle CTU are also equilateral triangles. So this was the meaning of marking points strategically. I have marked points PQ, RS, TU in such a way that these little mini triangles are going to be equilateral triangles. And since these are equilateral triangles, you can very easily see this angle is 120 degrees, and same goes for all of these angles. All these angles are going to be 120 degrees each. So let's reconstruct it here. I have PQ, then I have PR, then I have RS. Let's name them PQ, RS. We have T, ST, and then point U. Let's join these points. So we have a hexagon because we have 6 vertices, and there are some sides that we already know. PQ is 1 unit, RS is 2 units, and TU is going to be 3 units because these sides are part of these mini equilateral triangles. Not only that, all of the interior angles are already 120 degrees. We have already seen that. The only thing left is that we need to calculate the remaining 3 sides, and I'm pretty sure you might have guessed by now, these 3 sides are very easy to calculate. See, side PR is part of the original triangle side AB. So AB was 9 centimeters or 9 units, and from this AB we can subtract 2 units from here, 1 unit from here, so I will be left with 6 units. Similarly, ST is going to be 9 minus 2 minus 3, that is 5, and QU is going to be 9 minus 3 minus 1, that is 5 units. I made a mistake somewhere. Yep. ST is going to be 4 units. ST is 4 units. I made a small mistake here. So this is 4 units. Can you see it? I can see it. We have a hexagon. All of its angles are 120 degrees. It looks ugly, that's true, because it's a freehand drawing. It looks ugly, but all of its angles are 120 degrees, and the sides measures respectively 1 unit, 2 unit, 3 unit, 4 units, 5 units, and 6 units in a very weird order. And here we have it. The solution is really elegant. You can see we just had to construct an equilateral triangle, mark some points, and voila, we have the solution. I really hope you guys like this video, and if you like it, don't forget to share it with your friends, and don't forget to subscribe the channel. Thank you very much for watching. Have a nice time.